Well, I have one final story to close this out on tonight. It's about something called a gamma ray burst. And I'm going to show you a little picture here of it happening in the sky. Not terribly exciting necessarily. It's a spot of light that gets brighter in X-rays and gamma rays and then fades away. A typical gamma ray burst lasts a fraction of a second, less than a second. Those are called the short ones. The long gamma ray bursts, maybe 10 seconds, 20 seconds, maybe a minute is typical. Well, there was one that just happened early October that lasted 10 hours, and it was the brightest gamma ray burst we've ever found. So something was going on with that, something a little different, and I'm going to tell you about it. Well, first of all, what is a gamma ray burst? Well, gamma rays are just a form of light, another form of electromagnetic radiation. So visible light is another form of electromagnetic radiation, but our eyes are sensitive to it. We can see it. If you go a little bit shorter, you get ultraviolet. That's the stuff that can give you sunburns, but we don't see it with our eyes. X-ray is the same thing. We don't have X-ray eyes, but certainly your dentist can use it with the special detectors. Our bones block it, soft tissues do not. And then gamma rays are even more energetic. They're even shorter wavelength. They're so energetic, they can blow their way through skin and bone. They can be quite dangerous and create a lot of mutations if there's a lot of gamma rays around. So gamma rays are things that we kind of worry about. We don't want to necessarily have a gamma ray burst go off right next door. So we wanted to learn about these. When it was discovered there are gamma ray bursts that happen out there in space, we have space telescopes that search for them and warn us about them. When they see the characteristic of one happening, they'll notify one another where to go look so they can point the telescopes in the right direction and capture what happened. Well, it turns out that we learned and we believe that most gamma ray bursts have to do with the formation of a black hole. So whether it is colliding neutron stars that'll collide together and create a short gamma ray burst, or whether it's a supernova, a supermassive star, something 20, 30 times the mass of the sun, near the end of its life, an object that turns into what's called a collapsar. And turns out a colleague of mine in graduate school, a friend of mine that I was in school with, was the one working on this model with Stan Woosley. So Andrew McFadden and Stan Woosley came up with the collapsar model. And today we think this is probably what most of these longer gamma ray bursts are caused by, a star that actually collapses and explodes. So let's take a look at a little animation here of what that might look like. And that beam, that jet of material actually goes out both directions, but it's brightened in the direction you're facing it. And we think that to see a gamma ray burst, you need to be lined up exactly with that jet of material that comes out. The star itself has blown off its outer layers. The inner layers collapse down and form a black hole, but just outside where that black hole is forming, you form a jet of material that creates nearly speed of light speeds for this material as it shoots out of the star, burrows its way through, destroying the rest of the star, literally obliterating the star in this process. And it will be brighter than an entire galaxy for a while. Here's the actual data that was taken and put together into a little animation. The gamma ray burst is the brighter object in the top center there that gets very bright. The swath going sort of diagonally here, let's move the laser pointer across it, that's actually our very own Milky Way galaxy. So that's all the neutron stars and gamma ray bright objects glowing within the disk of our own galaxy. And this explosion that happened 2 billion light years away, so this is not within our own galaxy, despite the fact it looks like it might have been there, it outshone our own galaxy in terms of gamma rays by a lot for a brief period of time, even though it is 2 billion light years away. So this is in a galaxy completely somewhere else. In fact, this is a map of the first 500 gamma ray bursts, now that we have many thousands of them. But you can see they don't concentrate across the center of the Milky Way. You can take a look here. They don't line up with the disk of our galaxy or with the bulge of our galaxy. If they did, we'd see a whole bunch of points there. And well, we don't. They're scattered in every direction. So this tells us they're extragalactic. They're happening in galaxies beyond our own primarily. Well, what about this one that just happened? It was incredibly bright. Was this one in our own galaxy? The answer is no. Like I said, it was about 2 billion light years away. What we're seeing here is actually dust within our own galaxy reflecting those X-rays back at us. I think this is an X-ray image, and you can see the bright exploding star, the gamma ray burst happening here in the center, sending X-rays, and then a ring of them outside where there's some dust located there, and the light's actually bouncing off that dust and heading back towards Earth. And then a little bit later, this ring lit up, and then a little bit later, the very most outer ring lit up as that light had time to travel to it and bounce off that dust. So we're seeing all this stuff happening live, which is quite amazing. Now, is this dangerous for Earth? Could this gamma ray burst strip our atmosphere? Could it cause problems for us to live here? Yeah, something could like this. It would be a very bad day if one went off nearby. This one did affect our atmosphere, actually. There was some ionization that happened. Some radio telescopes that are actually designed to listen for lightning strikes noticed a change in their performance and their calibration exactly at the time that this gamma ray burst hit Earth. So they had these, they're listening for lightning strikes, essentially. Well, they got out of tune, is one way to think of it, due to the change in the way the atmosphere was working. Now, the good news is there's no stars capable of exploding as a gamma ray burst, as one of these hypernova or a collapsar. None close enough to Earth that we know of. We've mapped out a lot of the stars near us. In fact, most of them. It would have to be something like a pair of neutron stars somehow being very quiescent and quiet, but close enough and being able to merge that maybe could cause trouble for us. But there is certainly no 20 to 50 solar mass stars close enough to us to send a beam at us and to fry Earth and have a really, really, really bad day. So that's the good news here, is these things are out there. They are dangerous. They're rare, but there are not any close enough to us to really cause trouble to us. High note, Kitten, so we can end on a positive note. So anyway, gamma ray bursts, incredibly powerful explosions coming from supernovae, but we don't have to worry too much. There's not one going to be super close to us, and we can keep studying them.